There's a simple mistake that can turn a beautiful south-facing glass wall into a giant heat trap every summer, while the exact same windows could be helping warm your Barndominium in winter. The difference? What you put in front of the glass. Today, we're building the solution from scratch. A row of metal fins designed to block the summer sun without stealing the winter sunlight you actually want. And this isn't just about making the building look modern. I'm going to show you the 7 decisions that determine whether these fins actually work, where they need to go, how deep they should be, how far apart to space them, what materials make sense, and the small installation details that can prevent water, heat, and structural problems later. Because getting the fins wrong doesn't just waste money. You could end up blocking the sunlight you wanted while still letting in the heat you were trying to stop. Before you measure a single fin, you need to answer one question. What exactly are you trying to block? For most hot or mixed climates, the problem usually appears between May and August, especially from around 9 a.m. to 4 p.m. That's your overheated period, the hours when controlling solar gain matters most. But here's the first trap. Horizontal fins aren't a universal solution. They work best on south-facing glass, where the sun is high enough for a horizontal overhang to block it effectively. But if your windows face east or west, that morning and afternoon sun comes in much lower. Your horizontal fins can be sitting there looking beautiful, while the sunlight goes straight underneath them. That's where vertical fins, or another shading strategy, enters the picture. Now we need the number that controls almost everything else, the solar altitude. In simple terms, that's the angle of the sun above the horizon at the time you're designing the shade to work. And this is where your location suddenly becomes extremely important. A Barndo in one part of the country can need completely different fin dimensions from an identical Barndo hundreds of miles away. So don't guess. Pull your summer sun angle from Sun Path tool, such as NREL or NOAA, using your latitude. And if you're trying to control shoulder season heat too, check another date, such as late July. Now we get to the part that actually determines whether your fins work, the math. Fortunately, you don't need a complicated engineering equation. The basic relationship is fin depth equals height to be shaded divided by tan, summer sun altitude. The height to be shaded is simply the vertical distance from your fin down to the part of the glass you're trying to protect. And here's where things get interesting. At mid-latitudes around 30 to 40 degrees, a rough starting range can put the fin depth somewhere around half to 80% of the window height. Move farther north, around 40 to 50 degrees, and that starting range can climb towards 70 to 100% of the window height. But don't treat those numbers as a universal prescription. They're starting points. Your actual latitude, window geometry, and shading target determine the final design. A practical overall target is often around half the window height in total shading depth, with deeper systems approaching roughly 5 feet. Then there's the spacing problem. Put the fins too close together, and you've created a dark tunnel that destroys daylight and views. Spread them too far apart, and the sun simply slips between them. The sweet spot is to coordinate the spacing with your designed sun angle, so the shadow from one fin reaches approximately where you want it on the next section of glazing. Once you've got the dimensions, don't just start drilling holes into the siding. First, lay the entire system out on your elevation. A continuous rail or bracket line can sit above the glazing, or you can create separate mounting lines for stacked windows. And there's a simple trick that makes the finished result look far more intentional. Line the fins up with the window mullions or structural bays. On a metal Barndo, that alignment can make the fins look like they were designed as part of the building, instead of something added afterward. And pay attention to the lowest fin. Keep it high enough to preserve the view when you're sitting inside, while still protecting the glass from the strongest direct sunlight. Now comes the part that changes the look, weight, cost, and durability of the entire system. What are you actually building these fins from? You have 3 common directions: extruded aluminum, lightweight, corrosion-resistant, and easy to source in standard profiles. Steel or powder-coated steel, a natural match for the industrial Barndo aesthetic, provided it's detailed properly against corrosion. Or timber and composite, warmer and more residential looking, but they demand more attention to drainage and UV exposure. But whichever material wins, there's one rule you don't want to break. Anchor the fins to the structure, not the siding. That means finding the studs, girts, or steel framing behind the exterior. And if you're in a high wind or coastal area, don't underestimate the forces on a deep fin. The larger the projection, the more important proper bracketing and wind load design become. Here's the detail that rarely looks exciting in a rendering, but can become a nightmare if you ignore it. Water. Your fins need enough separation from the wall to prevent water from becoming trapped against the siding. And every mounting point needs to be coordinated with the insulation and air sealing strategy. Because a beautiful shading system isn't much of a win if the brackets create thermal bridges or become new paths for air and water to get through your envelope. And you can take the system even further. Pair the exterior fins with low-E or solar control glazing. Then use interior blinds for glare when the sky is bright, but the sun isn't directly hitting the glass. Now you're not relying on one layer of protection. You're building a layered solar control system. So before you build anything, here's the entire system in 5 decisions. 1. Use horizontal fins primarily where they make sense, especially south-facing glazing. 2. Use your summer solar altitude and the actual glazing height to determine fin depth. 3. Start around half the window height as a practical design range, but don't blindly copy that number. Your location and geometry matter. 4. Anchor the system into the structural frame and account for wind loads. 5. Adjust fin spacing and height so you control the heat without sacrificing the daylight, views, and character that made you want that glass wall in the first place. And here's where I can help you take this from a general idea to something much closer to your actual Barndo. Drop your latitude, your window height, and tell me whether your priority is maximum summer shade or maximum winter sunlight. With those 3 details, we can work through the fin depth and spacing instead of you simply copying dimensions from somebody else's building. And if this video just saved you from putting the wrong shading system on your Barndo, hit subscribe. Because every week, we're breaking down another small design decision that can make a huge difference once the building actually exists.